Welcome back. You already learned to join two streams in the earlier lecture. However, we also learned that the stream to stream join is massive in the state store. Every entry from both these streams is kept in the state store. We must implement some mechanism to clean the state store to avoid getting out of memory. In this video, we will learn to manage the state store for the streaming joins. So, let's start. I copied the earlier project with a new name. This is the same example. We have an impression stream and a click stream. We are joining both the streams to match them. However, I made some changes in this project. The first change is to replace the inventory ID with the impression ID. What does it mean? An impression ID is always unique and it cannot appear twice. Every time an impression is shown on the portal, it gets a unique ID. The portal ensures it. When a user clicks on the impression, the same impression ID is passed with the click event. So, the impression ID is the ideal candidate to join the impression event with the click event. And that's what we are doing here. That's all. No other change in the data model. If you try running this example, it should work in the same way. However, we wanted to address the state store cleanup, right? We already learned that Spark uses watermarks to clean the state store. So, if you want to clean the state store, you must apply a watermark to both the streams. Let me do it. Here is the code that creates an impression data frame, right? All we need to do is to call the withWatermark method. We want to watermark it using the impression time column and give it a 30 minutes of watermark. What does it mean? Simple. We are giving 30 minutes for the impression to arrive at the Spark. If the impression takes more than 30 minutes to reach the Spark job, we want to ignore it. Make sense? Now let me give the same watermark to the click event also. Done. We have the watermark and Spark should now clean up these records from the state store. Let me run it and show you how this works. I am starting the Kafka services. Great. We will start with two impressions. Both the impressions are timed at 10 AM, right? Then I'll push one click event as well. The click event is generated for impression 101 and it is timed at 10:15. Now, if I run the application, what do you expect? The impression 101 and the click 101 should join and they should appear in the result. However, the impression 102 should not appear in the result. Both the impressions and the clicks should be kept in the state store, right? Let's try it. Here is the output, as expected, right? Now let's do some computation for the watermark. What is the max event time for the impression stream? 10 AM, right? And what is the max time for the click event stream? 10:15 AM, right? So the watermark boundary for both these streams become max event time minus 30 minutes. So we have 9:30 watermark boundary for impressions and 9:45 watermark boundary for the click event stream. Make sense? Now let's send one more impression event 103 for the next micro batch. This one is timed at 10:46 AM. I also want to send a matching click event timed at 11 AM. What do you expect now? Both the event will match and they should appear in the output and they should also go to the state store. However, the max event time will change. and hence the watermark boundary will also change. So what is the new watermark boundary for the impression stream? 10:46 minus 30 minutes equal to 10:16 AM, right? And what is the watermark boundary for the click event stream? 11 AM minus 30 minutes equal to 10:30 AM, correct? Do we have any older events to clean up? Impression 101 and 102 are now below the watermark. The click 101 is also below the watermark. So Spark will clean them now. If you send one more click for impression 101 or 102, will they appear in the join result? No, right? Because the state for those impressions is already cleaned. Let's try it. I'm sending one click for 101 and another click for 102. Let's see if these clicks appear in this microbatch result. No, we got an empty output. And you know the reason. The older events were outside the watermark and so they were cleaned. Now Spark is considering these click events too late and ignoring them. So they do not produce any output. Make sense? Great. Let me summarize. Spark stream to stream join will hold all the records in the state store. However, you can specify the watermark on both these streams and Spark will start cleaning records that are going below the watermark. Watermark is optional for inner joins. However, joining two streams that do not have a watermark will fill the executor's memory very quickly and you will start seeing the out-of-memory problems. However, you should remember one thing. Cleaning the records from the state store below the watermark may happen immediately as soon as the record goes outside the watermark boundary. Or it may be delayed by Spark as part of some optimization. So, Spark does not give a guarantee that the records outside the watermark will be surely ignored. However, Spark guarantees that the engine will never ever drop any data that is within the watermark boundary. Great, that's all for this video. See you again in the next lecture. Keep learning and keep growing.